Stonehenge is the most iconic and intensively studied prehistoric archaeological site in the world. For centuries, the site has generated curiosity and wonder. But it was in the 17th and 18th centuries that the importance of Stonehenge's landscape became recognized. With so many upstanding monuments visible within the landscape surrounding Stonehenge, it isn't surprising that these have largely remained the focus for archaeological investigations. The construction of Stonehenge commenced approximately 5,100 years ago. Repeatedly modified, it reached its recognizable form about 3,600 years ago. But the landscape of Stonehenge reveals evidence from 10,000 years of activity, starting during the Mesolithic and leading all the way to the present day. The majority of previous studies within the Stonehenge landscape have focused mainly on the upstanding monuments that remain visible today. However, much more is buried and not visible at the surface. Advancements in the technology for investigating archaeological landscapes by the Ludwig Boltzmann Institute made it possible to explore the entire hidden landscape at a high resolution, starting in 2010. By mounting a wide array of equipment to vehicles such as quad bikes, and by linking the collection of data to GPS satellite navigation, it was possible to undertake a survey at a scale and resolution that had never been attempted before. It became possible for the first time to get additional information about known sites within the landscape and to fill in the gaps between monuments. A total of approximately 12 hectares was surveyed between 2010 and 2014. The ambitions of the Stonehenge Hidden Landscapes project were achieved through European cooperation, with an international team directed by the Ludwig Boltzmann Institute and the University of Birmingham, and involving the universities of Bradford, Vienna, St Andrews and Ghent. The project has used a range of different techniques for the non-invasive exploration of the hidden landscape. Geophysical techniques measure different parameters of the soil to generate 2D and 3D maps of buried archaeology. The principal methods used were magnetometry, measuring variations in the magnetic properties of the soil, and ground-penetrating radar, which provides 3D imagery of buried features. Other geophysical methods were also used, including sub-decimeter topographic laser scanning of the entire landscape of Stonehenge. This project has shown that it is not possible to appreciate the significance of Stonehenge itself without understanding the landscape around it. The high-resolution survey of the known monuments around Stonehenge has significantly increased the level of knowledge about them, in many cases allowing us to identify different phases of construction and presenting quite different interpretations to those previously held. By surveying the areas between the upstanding monuments, the project has revealed a multi-period landscape far from the empty space previously imagined. This includes a range of new monuments contemporary with Stonehenge, including similar, though smaller, hengiform sites. We can now see a landscape dotted with numerous smaller temple sites constructed of wood, stone and earth, surrounding the larger site of Stonehenge. The increased knowledge about the hidden landscape of Stonehenge has meant that it is now possible to explore the evolution of the landscape through time and how the different monuments might have been used. To obtain high-resolution detail, multiple geophysics sensors were mounted closely together, providing dense sampling intervals. The higher resolution meant that smaller features, such as small pits and even post holes, could be identified. Features that would have been missed using conventional approaches. Stonehenge could never really be understood when we knew so little about the landscape in which it stood. We now understand that it was surrounded by smaller shrines, which were completely unknown until this groundbreaking study was completed. We need to know much more about this enigmatic landscape, but we can be sure of one thing. Cutting-edge remote sensing and geophysical prospecting have fundamentally changed how we interpret the Stonehenge landscape, and how archaeologists will study similar landscapes in Britain and around the world in the future.